servers in the wild will be presented by Mohan, Nitinder.
Okay. Hello, everybody. My name is Nitinder. I'm from University of Helsinki, and today I'll be presenting my work on Anveshak. So to start it all off, I'm building up on the talk that Victor gave this morning, and I'll briefly run into what we call or what we mean by edge clouds and edge servers here. So from all the research that has been done in this work, the overall idea that has emerged is that edge servers are these small-scale servers that are deployed at the network edge, which it means is very close to the end user, and it does the computation very close to the users so that they are not sending data to the end cloud, which is at much higher latency. Obviously, the motivation of why people are churning papers in this work right now is because the servers can greatly reduce the latency, which is very needed for many of these applications out there. And what it also does is it reduces the network traffic that the users are generating and putting over the network, which is essentially making the network congested, right? If you're looking into IoT-based applications and the number of sensors that are being deployed to just run one kind of an application, this second part of the first motivation is quite important here. The second thing is that because these servers are quite small and can be deployed in much higher quantities, what they can actually bring to the entire solution is some part of local relevance, that the data being generated can now have some compute relevance along with it. Uh, but only these two motivations are driving the models, and various kind of abstraction models of how these edge clouds should be deployed have been proposed. But when we look exactly into what these small devices are, several questions emerge. Some of them have already been asked in the keynote this morning, and which are like, what are the configurations of these kind of machines, right? Who owns and operates these machines? If you have an SLA, who's actually operating it? Is there kind of a revenue system model that is already built in? And the question that is important for our talk here is that what is exactly the physical locations of these servers that are being deployed, and how do you choose these deployment locations? So that brings us to this model that I have somehow abstracted from all the research that has been done. We call it the physical edge cloud model. So when we look at any location and we try to find out where the actual deployment of edge servers are going to be, we kind of run into the assumption that all the models that have been proposed, they can run simultaneously in the same kind of a location, right? And the availability of each kind of a server of different models is actually going to drive the utilization of the servers that are already available in that location, maybe from a different kind of a model. This is somewhat very similar to the availability or usage of LTE-based or cellular-based internet traffic when you have a Wi-Fi available in your location. So you're obviously going to prioritize Wi-Fi, then you go to a cellular kind of a network. The feed and the foremost, the food of all of this deployment is actually the users, which are the subscribers and the requesters. And they're going to make requests of doing some computations, some kind of small relevance of the data that is being generated. The user density is actually going to drive where your edge server should actually be placed in any location. It has been shown by multiple researchers in the past that the user density is actually very much dependent on the time and as well as the behavior of the users. For example, the users are much more active during the daytime, so a lot more requests are going to be made during the day than during the nighttime. Also, there is more population in city areas, so there's need to be a more kind of a density of edge servers in cities than in suburban areas, right? So next we come to the class of research of edge clouds, which have been proposed like edge-centric compute clouds. So these are your radical ideas that edge is going to be running on mobile devices, or they're going to be controlled by the end users themselves. So these kind of servers are actually your very small servers, very less network and compute capable, and they're going to be mostly managed by the user. So that is why we call them user managed edge rather than giving them any kind of a different keyword. Uh, these kind of devices have already started popping up in the overall network. You have various markets already built in for them. For example, you have smart speakers, you have intelligent Wi-Fi hubs, you have your home automation devices. So these are all these normal devices which are now fitted with a processor to do some basic tasks. And as we move in further, there are going to be more different kind of devices and more processing power that keeps up cropping up in this area. The one thing that I would like to bring to your attention here is that because these are only controlled by the users themselves, they are all the deployment and their availability is also very much dependent on the user density and population. So because they're catering to only a several set of users, so they're not going to be having a very large umbrella of networking around them. The next layer, on the other hand, is the one that have been proposed by various researchers. These are your fixed edge clouds, your fog clouds, you have your cloudlets. So these are your compute capable, network capable devices that are going to be deployed only to cater to users and will have some kind of a revenue model built in. Because they will be operated by your SLAs, service providers, or whatever we call them, your service provider managed edge. Uh, and what we assume here and what the researchers have also proposed in the past is that these devices are going to be either co-located with an existing base station that is out there, or it is going to be accessible via a base station network, right? So that you have a very low latency. The actual deployment and availability of these resources is very important if because you're going to be charging money for this kind of a subscription model. But these devices, because they have high communication areas, so you have low server density where one server is going to be catering to a large set of devices here. So that brings us to the question for the stock. What if you're working as a service provider and now you're entering into the realm of edge clouds and you want to find out, okay, what is going to be the best selection of this location that I should start putting in my money and I should start provisioning these location with some edge servers. How do you divide that? Well, you can follow these two approaches here. Number one, you can be naive and you can say, okay, everybody in the base, every base station in an area gets an edge server. What do we have to lose? Every user that we get can access this service, so it's pretty good for us, right? But the problem is you're going to run into over-provisioning here. And this is quite a lot of problem because your connectivity of these base stations are going to be overlapping. So it's not like you're catering to a new set of users. It's just that same set of users might be getting connectivity from different kind of areas. And second is your utilization of the edge servers are quite important because you're actually putting in money for that. So you want these servers to be running into their actual capabilities. You don't want to running them idle. The second is if you're going to be Scrooge about it, you only say, okay, I will select one location and maybe other people through the base station network can connect to this location. The problem is, again, the under-provisioning here. It's going to be hard for you to maintain a minimum quality of service that you're promised to the user because you're charging money for it. And second is, it will be difficult for you to support the peak traffic rate that might hit you at any point of time and you're not prepared for it because these are fixed locations here. So considering these in mind, there is actually a need for a deployment framework which actually figures out what are the best location for deploying these edge servers out in the wild, right? So such kind of a deployment algorithm must, number one, prioritize any locations of users that are already existing in the area, and you need to predict where these user requests might be coming from in the future. Number two, you would like to avoid areas where there's already high concentration of these user-managed edge servers because it's the same principle as that of Wi-Fi and LTE base station. Because if you have a local device available, you're not really going to go to your own managed cloud, and users are not going to really pay money about it. So considering these two in mind, we bring to Anveshak. Anveshak exactly does this job. So it follows overall, the system workflow follows a three-phase kind of a model. That's how we designed it. It's a waterfall-based like model where each phase is succeeded by a checkpoint so that you can recover from any failures or you want to change any kind of a phase in the middle, that is fine with us. As we go deeper into the stock, each phase is then divided into multiple modules, which you can swap if you have better algorithms available for it or you need to do something else. Again, we are keeping it open to the usage of the service provider themselves. But what Anveshak bring to the table is because it's a first of its kind framework which actually tries to predict where the availability of user managed edge is going to be in the future, and then it uses it for current decisions of deploying any kind of edge servers. So that brings us to the first phase, right? The first phase is actually user mapping. So what we try to do in this phase is we try to identify and prioritize any areas, which is our first point, that might have any high user request or communication request that is arising from, because we want these locations to have edge servers as much as possible, right? We want to have high server utilization, which is what these going to provide. And the actual selling point of edge servers is you want to have a low user to server latency, which is why you need to figure it out. So this phase is composed into multiple modules, and I'll go into one by one quite quickly because we're short on time. So the first one, what we do is we divide the entire space into an equi-space grid. Why do we do into the grid is because later on we do cluster the users, and grid-based mechanism provide us consistent clustering. The size of the grid directly affects what your problem search space is going to be in later phases, which we can discuss later, but we leave it open to the runner who is actually handling this model. So after we divide it into the grid space, what we do is we can position any kind of user requests that have been made into the area. This is based on the fact that a service provider might be actually running in collaboration with an ISP, and these user requests are actually similar to your call detail records, any calls that the user might have made, or any internet initiation requests that the user might have made. That gives us kind of an idea how users are interacting with the network out there, right? So these requests, however, are averaged over some period of time because we want to remove any kind of temporal outliers there. For example, there might be some concerts that might be happening which have a high concentration of users making requests or uploading some videos. But these are not actual consistent location where users are always available. So we would like to avoid that. Once we have done that, what we do is we cluster these requests based on their inter-request densities and your distances between the requests. The choice of the clustering algorithm, again, is open to the service provider. You can swap it, but for this talk, we use dbScan, and it can be easily tweaked as a module. Once we have already clustered these resources, what we do is we then generate a heat map on the grid by mapping these clusters based on the densities. This is quite important for us, as I mentioned earlier, because we want to avoid any kind of inconsistencies of the underlying clustering mechanism that we are having, or because we have averaged the user requests over a pattern of time. We want to get away with any kind of request patterns that we might have missed. Also, the clustering algorithm might give us irregular shapes, which might not have any possible edge locations in later phases. So a grid-based mechanism actually gives us a larger area to work with. Once we have done that, we kind of get these a 2D array of a grid ID and the request density of user that are available in this area, which we feed into the next phase, and this is the user edge incorporation, as we call it. In this phase, we try to figure out what are the possible deployment areas for user-managed edge in the same location, because these devices are directly going to affect the utilization of your deployed edge. For the current research, we found out that looking at the availability of Wi-Fi access points in a location actually is very similar to availability of edge in the future, because the way they are operated, managed, and controlled is somewhat quite similar. They're completely being controlled by the users themselves, and therefore you can get a sense of idea of how it's going to progress over the years. So taking that into account, we start with some open data sets that might have a list of all these Wi-Fi access points. Several of them exist. We look at wiggle.net. They provide a nice set of all these Wi-Fi access point availabilities because they're crowdsourced by people like us. What we then do is we filter out any kind of mobile hotspots or any temporary access points over the period of time, so that we get out these access points which are consistently available and set up by users in their homes or their offices. Once we do that, we map those access points on the heat map that we generated in phase one. After we have mapped them, again, we do the clustering based on the densities. And then what we do is we reduce the request densities of the heat map based on the availability of Wi-Fi access points in the same area. So this you can see, for example, here, you had some high request densities available in this location, but also some Wi-Fi access points. So what we do later on is we reduce the densities, because the availability of these resources might lower the availability of your request going to the setup server. So the resulting heat map is actually a set of all grids which have user requests which are overflowing and have more probability of running into your managed edge server, which is denoted by that list. So for the phase three, I will not go into much detail, but what we exactly do is then we prioritize the list of locations which have much higher priority of a much higher probability of getting user requests based on the densities. And then we map any available base stations on that area. These base stations are possible locations where the edge server can be deployed. If there are more than one locations, then that problem leads us to a facility location problem kind of an algorithm, and several other solvers are available for this, which kind of approximates it. But feel free to check our paper for more details on that. So that brings us to evaluation and how does Anveshak perform in this placement. So while checking out the evaluation, we try to find out what are the best ways of placing K base stations or edge servers in n possible locations in the city of Milan. So what we do is we divide the entire city into 100 cross 100 grids, where each grid is about 235 cross 235 meter in its area. And we use several real data sets to feed our algorithm for this. For a user request, we use the one which is provided by Telecom Italia. This is a 2014 data set. They have a set of CDRs available and internet initiation records that we use to feed that these are the request arise locations. For base station location, we use the OpenCell ID data set, and for user managed, which is Wi-Fi, we use the Wiggle. Then we compare Anveshak with two different approaches. The first one is greedy, which does the phase one exactly as is, that it prioritizes location with user edge and then puts the base stations over there. But it doesn't look into the availability of Wi-Fi access points. Then we use, the other one we use is random, which we're just comparing with randomly placing any K base stations. So the setup is that a user is mapped to the nearest base station using any coordinate-based latency approximation approach, and then the deployment framework needs to select 50 base stations for best supporting these users out of the possible 850 available in Milan. So the first thing that we look into is the user request satisfaction and how much is the place server computed by any kind of deployment framework is able to support the users that are in that same location. So the graph is shown here, and the overall overview is that we can do 67% more requests than the closest competitor, which is Greedy, where the salient point is that 25% of those requests are actually handled by the first 8% of selected base station locations by Anveshak. If you are a little bit worried about the number 67%, that is not high enough. It's basically because we are only limiting our selections to 50 base stations. But if we let the algorithm run wild and select as many number of base stations, we can achieve 90% user satisfaction by placing 124 base stations edge servers, whereas the greedy needs to do 200 and random needs to do 300 plus. Then we need to lead into the server utilization, whether we are able to keep the server running for longer and how much. Again, Anveshak trumps the greedy over here. We achieve 83%, whereas the greedy achieves 66%. And the reason why it does that, because greedy prioritizes location which have more number of users, but usually these locations also have more availability of Wi-Fi access points and possibly more probability that there is going to be edge servers in the future. So that is why it kind of loses it in the battle. So that brings me to the end of this talk. In an overview, Anveshak is a deployment framework which is aimed towards service providers. And what we try to do is we efficiently try to compute any locations which will be the best locations for deploying any service managed edge in the future. We look at the density of user requests, also the probability of what is going to be the user managed access points in the same location. We evaluate using several data sets, and we achieve quite good results in this. So thank you so much, and I would take any questions. Yeah. Hmm. So, sure, perfect. I would probably go into my backup for that. So this is the kind of data sets that we got, right? So if you look into this is the availability of base stations in the Milan area, right? So if you look, these are kind of uniformly distributed over the entire map. Because what ISPs are aiming for is consistent connectivity no matter where you are, and they have to set up base stations even when the users are mobile or they are connecting on the move. But if you look into the Wi-Fi access points in that area and after filtration, what we see is there is a high concentration in the city center where the users are actually more located. And there are not many users on the sides or the suburban area of the base stations where there is availability of base stations in that area. But again, there are much more higher concentration of users here. So if we do our filtration in the first phase, we kind of take out all of these areas which are not going to give us the best results because we are paying money for it. And we would focus more on the areas which have high concentration of users. Yeah. Hmm. Yeah, sure. I mean, but again, how much preference do you want to give to the availability of Wi-Fi access points is again dependent on the service provider. But what we argue here is if you would like to put in edge servers in location not looking at the availability of Wi-Fi access points because there are prime locations where edge servers will be deployed. Even though there is 5G out there, there is other products that are coming up which are actually making Wi-Fi access points intelligent. Yeah, sure, sure, sure. Oh, sure. That definitely is a different network. But our reason why we look into access points is because they behave in terms of their deployment and their ownership. They behave very similar to how a user managed edge would operate in the future, even though if it is mobile devices or any kind of devices that user purchase for automating their home or making them smart enough. So that would give us a basic idea. Obviously, it's not a solution for the current times right now because it's looking outwards in the probability of the future, but that's how we account for any possible outliers.
I think we need to stop here.
Okay.
Thank you very much.
Yeah, thank you.